Okay, good morning or afternoon, evening. I don't know what time you people are taking these notes. Hopefully you have the 5 graphs that I sent home with you yesterday. If you weren't at school, you wouldn't have these graphs, so you'll just kind of have to sketch them the best you can. But those of you that were given these graphs, please use them. Of course, you'll need glue, and I'm also going to be using a blue color pencil today for this. We are going to start graphing linear inequalities. It's really exciting stuff. So up until this point, we've been solving all these equations and all these different ways to show, slope, intercept, point, slope, standard, all that jazz. And now we're going to move into graphing inequalities. And I'm not talking like a line graph or a number line. I'm talking like an actual graph. So let's go ahead and jump into this. First, we're going to start when there's just one variable. Okay, so that's going to be our baby steps into this. So we're going to start with the inequality x is greater than or equal to -4. All right, so that tells us that all values are -4, all x values, let me erase that. All x values are -4, so we're going to have a vertical line. Right. If it was y, then we would have everybody from home? Yes, a horizontal line. I know the anticipation was amazing. Okay, so what I'm going to do is I'm going to glue in my first graph to go along with this. Got my beautiful graph here. All right. And I'm going to go ahead and graph this. There's a couple things I need to keep in mind. Because this is or equal to, I'm going to have a solid line. Kind of like on a number line when we would fill in the point. Do you remember that? Because it was or equal to. So very similarly, there's a different thing on these linear inequalities as well. So I'm going to draw a solid line at -4. And then, of course, I'll show you guys what it looks like if it's not or equal to. So I know this is kind of hard to see on here. There's my line at -4. Okay. And then I'm going to substitute 0 for x to see if it works. So what does that even mean? So go ahead and write it down. Substitute 0 for x to see if it works. Okay, so what that looks like is I'm going to put a 0 here, right? So now I have 0 is greater than or equal to -4. Does it work? Yeah, 0 is greater than or equal to -4. So since that works, that tells us that the point 0, 0 is going to be a solution to this linear inequality, right? So since it works, we're going to shade towards 0, 0 on the graph. Okay, so here's where my blue pencil comes in line. And I'm just going to shade all of this part of the graph. So it makes sense, right? If x just has to be greater than or equal to -4, any x value in this shaded area is going to work. And we proved that because we just used a very easy number 0. I could have used any number, honestly, to the right of this. I just think 0 is the easiest one to focus on. I could have used -2, I could have used -3, I could have used 3. All of those would have proven that I needed to shade this direction, but I just find it easier to use 0, 0, or 0 when there's just one variable. so that I don't have to overthink it. I mean, 0 is pretty easy to manipulate, right? Okay, so this shaded area then represents all of the x values that would work for this one variable linear inequality. So let's try another one. Of course, if we have an x, I'm going to make you do a y. So y is less than 2. So that tells us all y values are at 2. So we have a horizontal line. So I'm going to glue in another graph. I hope it fits. Oh no, it's not going to fit, is it? All right, you guys are going to hate me for this. I'm going to erase and rewrite this. So just be patient because I can't really stop the video. I know that sounds weird, but I can't. So give me 1 second. I really need this graph to fit on this page. I'm sorry, guys. I'm using different graphs than I have in the past, so I didn't realize that it would be that much bigger. Okay, so if we scoot it up 1 line, y is less than 2. So all y values be at 2. So we will have a horizontal line. Okay, fit. Oh my gosh, you guys, it like barely fits. I'm gonna use it. We're gonna go with it. If you know yours wasn't gonna fit no matter what, of course, if you went to the next page, that's fine. Oh, how am I gonna do this? Okay, and I might get my scissors out here. We're just improvising, guys. It's okay. Just cut off the bottom of this page. That'll have to do. Okay, it's not pretty, but you know, it is what it is. Okay, so remember up here how we had a solid line because it could be equal? Down here, we're going to have a dashed line at 2 because it can't equal the 2. So like I said, with the number lines, remember we would have open or closed plot. Well, this time we have to have a dashed line so everybody in the math world knows it can't equal 2. It's going to be less than 2. So then I'm going to substitute 0 again. For y to see if it works. Okay, so is 0 less than 2? Yep, 0 is less than 2. So I'm going to shade towards 0, 0, just like I did for the first one. So everything down here would count as a solution for y because all of these values are less than 2. Again, I used 0 just because it's an easy number to think about in our head. We don't have to overthink it, right? Okay, so that's our first page, and I believe this should be page 34 for your notes, or at least for mine. Okay, so let's move on to page 35. So that was with 1 variable. Let's move on to 2 variables. This is exciting stuff, guys. Okay, 2 variables. All right, so we're going to do a few examples, and that'll be it for today. So we have opposite of x plus 2y is greater than 2. All right, so we almost have something in standard form. Not quite, because it's breaking that rule there. But first thing we have to do is rearrange to slope-intercept form. You guys thought we were done with it. We're not. We're just using it in a different way. Okay, so if I have opposite of x plus 2y is greater than 2, easy peasy, I'm going to add the x. 2y is greater than x plus 2. Divide everything by 2, so I get y is greater than 1/2 x plus 1. All right, so now I have its slope-intercept form. I know my slope is 1/2. I know my y-intercept is 0, 1. Awesome. So now I'm going to graph this. So let's go ahead and glue in another graph. Okay, so I've got my graph here, plenty of space this time. Oops, sorry guys. Plenty of space. You can see my little eraser marks. Okay, so a couple things from the previous example. I am going to have what kind of line? So when you look at this linear inequality, what kind of line am I going to have? Hopefully you guys are saying it's going to be a dashed line because it's only greater than. There's no equal to. So I'm going to plot my, graph the line, plot my y-intercept, and use my slope to graph it. So my y-intercept is 0, 1, and my slope is 1/2, so up 1 over 2, up 1 over 2, maybe I go down 1, back 2, and then I'm going to connect these with a dashed line because it doesn't equal these values. Easy peasy. And now is where we're going to substitute again, except we're going to use 0, 0, 0 for the x, 0 for the y, to see if it works. Okay, so we've got y equals 1/2 x plus 1, 0 equals 1/2 times 0 plus 1. Does 0, oh gosh, you guys, I have equals here. What am I doing? Greater than, 0 is greater than 1. Okay, so is 0 greater than 1? Hopefully at this point in your math career you can easily say nope. So that tells us we must shade away from 0, 0. That tells us at this point 0, 0 doesn't work in the inequality. So if it doesn't work, it can't be a solution, which means everything above this would work. So that's how we know how to shade above. Right? So if I were to substitute in 0, 2, that would give me is 0 greater than 0, 2. I would have a 2 here, and yes, 2 would be greater than 1. So that's how that works. I know it's weird and it's kind of new and we're not really sure and it's uncomfortable, but that's what we're doing today. All right, so let's go on to the next page. That was 34. This was 35. I'll leave this here for just a second in case you need to pause and copy. We're going to do another example here. Example 2. I'll try to be better with my camera here. We have 3x minus y is greater than or equal to 5. So again, we have to rearrange this into slope-intercept form. So I'm going to subtract 3x from both sides. Sneak that 3x in there. So I have negative y is greater than or equal to negative 3x plus 5. We know we can't have this negative y, so we're going to use our super trick of dividing everything by negative 1. Now, when I divide by a negative, remember I have to flip my sign. So I actually get y is less than or equal to 3x minus 5. So don't forget to flip the sign. Write yourself a little note. All right, it's easy to forget to do that. Okay, so now I'm going to glue in another graph with plenty of space. Right up here next to it. Okay. I know that my slope is 3 and my y-intercept is 0, negative 5. So I'm going to plot 0, negative 5. My slope is 3, so up 3 over 1, up 3 over 1, up 3 over 1. Now I have to ask myself, do I draw a solid line or a dashed line? If it's equal to, it's going to be a solid line, right? So since it's less than or equal to, that's going to be a solid line there. So let me go ahead and connect these points. Remember, I advised to do 4 so you can get a really accurate line. And now I'm going to do that trick where I substitute in the ordered pair 0, 0 for x and y. So I have y is less than or equal to 3x minus 5. I'm going to put 0 in for y, 0 in for x. Is 0 less than or equal to negative 5, right? Because 3 times 0 is 0. 0 minus 5 gives me negative 5. And that's a no, right? So that tells me that this ordered pair right here, 0, 0 on my graph, not a solution. So that means I have to shade everything below this line. So that tells me that any ordered pair below this line will make the inequality work. Hopefully you're kind of picking up on this pretty easy. All right, let's do another example. We've got opposite of x plus 4y is greater than negative 12. I'm going to add x to both sides to get it into that slope-intercept form. Remember, I'm sneaking the x in there. So I've got 4y equals x minus 12. Not equals. Guys, I can't get over that. 4y is greater than. And then I'm going to divide everything by 4. So I'm going to get y is greater than 1/4 x minus 3. I didn't have to flip my sign because I did not divide by a negative. Right? So let's go ahead and glue in our final graph for today's notes. And I'm such an expert at this, I know that my slope is 1/4 and my y-intercept is 0, negative 3. So I'm going to plot my y-intercept, and then I'm going to go up 1 over 4, and then I can go down 1, back 4. Looks like I can only fit 3 points on this graph, and that's fine. And then I have to ask myself if I'm going to use a solid line or a dashed line. Okay, hopefully in your head you're thinking, dashed, Mrs. Marsh. I know it's a dashed line, and you're absolutely correct. So you're going to put those dashed lines in there. And then now we're going to do the 0, 0 trick, right? So we're going to take our linear inequality, y is greater than 1/4 x minus 3. I'm going to put 0 in for both. 0 greater than 1/4 times 0 minus 3 is 0 greater than negative 3. Sure is, right? So I'm going to shade toward 0, 0 because it does make the inequality work. So now I'm going to color all of this space up here. Okay, so now I have my graph of my linear inequality. This is so exciting. All right, so that's our notes for today. Hopefully you guys found them not too terrible. We ended on page 36, okay? Of course, if you have any questions, the nice thing is I will see you tomorrow, and we can practice some in class and take some more notes. And yeah, so don't forget to subscribe. I did talk to classes on Friday. I noticed that some of you have unsubscribed. I'm trying not to take it personally. You really don't have to subscribe. I know it's obnoxious because then you end up getting notifications every time I do something, but I just don't want you guys to forget that these videos are there. All right, thank you. Have a great day.